In this tutorial we're going to learn how to make a Revit door family that has the appropriate parametric capabilities to give yourself the ability to open the door in 3D, so it has a 3D swing. Also the 2D swing is able to operate as well, and this door has true profiles for the actual frame, so that it can either be within a chipboard wall assembly or a masonry opening. And you can kind of see here real quick when I'm just changing some of these parameters that kind of when we're done we're able to open and close the door in 3D, so that if we're doing 3D renderings and we want to be able to look into a room, we might have that capability. And then also I can adjust the 2D swing so that when I'm working on a floor plan I have the ability to make sure I don't have a lot of doors essentially intersecting one another. One thing that you'll find with Revit is the door families that actually come just out of the package don't give you a whole lot of options. There's the single flush door. A couple of things about it, it's okay for just kind of starting out, but there's a couple of things that's wrong with it. One, there's just a panel, it's got the door trim that's around it, but it doesn't represent a hollow metal door frame, which is pretty much the most typical door frame out there that you're going to be using in commercial construction. This one's more of a wood trim door, and even then it doesn't really have all the parts and pieces to it. It's just kind of a generic representation. Also, in a floor plan view, everything's always at 90 degrees for the door swing, so you're not able to really adjust this unless you want to do a lot more drawing and so on to adjust it and then make a new door type. So what I'm going over here today is to make a all-purpose door that can not only have the solid door panel, but it's also going to have the ability to change the door panel into a door panel that has glazing, and it also has all these abilities to adjust. So what we're going to do is I'm just going to close out of all of this, and I'm going to open back up the door that I was in. So in this door family, it's actually made up of 3 parts. We've got a extruded sweep that makes up each side of the frame, and that extruded sweep is going to reference a profile family. So basically we need to have a 2D profile that's able to mimic the shape of the section that we need when we look at our hollow metal frame. It also has a 3D door panel that will also be a separate family. That can either be something that has glazing in it, or it'll just be a solid panel like you see here. And then the third family associated with this door is the 2D swing, which is basically made up of a generic model that has 2D symbolic lines that make it kind of move. Putting all these things together as 3 separate files makes it all work together. If you try to do it all in one file, you do run into a lot of errors as you're working. So starting out, looking at the actual frame profiles, we've got basic 2 conditions, and I'm just kind of looking at an old set of drawings here obviously, but there is the condition when a hollow metal frame is within a CMU enclosure or opening, and then you've got the condition when it's intersecting with a chipboard assembly. The difference is usually with the CMU you are butting into the side of this. Normally the frame is maybe flush with the CMU, and the depth of the whole entire frame is usually customized. And then when you have the gypsum wallboard assembly, your hollow metal frame is usually wrapping around that assembly. So you can see those 2 different conditions there. And then we've got different dimensions for each frame type. So this one was referencing frame profile D, and this one is B. But really the only difference here is actually, according to B and D, there is no difference. They all have the same exact dimensions, except for that rabbit leg at the very back here when it comes back is different from a B versus a D. So anyway, that doesn't really matter too much. What we're going to do is make that profile so it's parametric. Also, we're going to be making these door panels. I'm not going to ignore the one that has a louver in it. We're just going to assume this one's a solid panel. That'll be the easy one. Then we've got one that has glass in it that's kind of in the upper part of the door, and then an overall door frame, or not door frame, but door panel that has pretty much all glass and just a small frame around it. So what we want to do is go ahead and go into Revit, and we're going to open up our families and go to a new family template. This new family template will want to be working in a profile family so that we can make those double rabbet door frames that are hollow metal. Now the idea always with making something parametric is to make a lot of reference planes that are assigned to dimensions, and then ultimately have our 2D lines connect to them or lock to those so that they can move with the reference planes. So in this case I'm going to kind of mimic basically wherever you see a dimension line and you see those stringers, I'm going to make that a particular reference plane. So here if I go to create and hit reference plane, I'll go ahead and make a vertical off to the right, and I'm going to make a horizontal off to the top here. We can strike a dimension between these, and I'm also going to change the scale down at the very bottom so that our dimensions aren't so big. And with these first set of dimensions, I'm going to call this horizontal one, if I go to label, I'm going to add a parameter, and I'm going to make this parametric by calling this a face frame, we can call it face frame width. We'll keep it as a type and click OK. Now when I go to my family types dialog box by clicking on create in the family types, in this dialog box I want to make this dimension 2 inches. That's a very typical hollow metal frame width size. Now the other one is the depth, so I'm going to click on that, hit add parameter, and I'm going to call this frame depth, keep it as a type, click OK, and for now let's just make it some kind of whole number, like 8 inches. That frame depth is always going to vary, it depends what type of wall it goes into, and that's your responsibility eventually to tell a contractor what each door its particular depth is going to be when that frame is in that wall assembly. Now a couple other reference planes that we need. I need one that's representing sort of this rabbet bump out, and the rabbet depth, which is this 1 15/16 and so on. I'm not going to worry about the one in the middle because that one's going to be variable. So what that means is I need a couple more reference planes that are horizontal. And I'll strike a dimension from the bottom to that first one, and then from the top to the other one that we made. And I'll make both of these by holding in the control key and selecting those, add parameter, and I'm going to call that rabbet depth. Again, that's a type, and we'll click OK. Now the rabbet depth we'll go ahead and set to whatever it was already, which is 1 15/16 of an inch. And then I need to deal with that bump out, so I'm going to go to reference plane, make a vertical, and then make a dimension that can be called rabbet width. It looked like from the drawings that is at a 5/8 of an inch, which by the way, those drawings are old, but not much has changed in the design of a hollow metal frame. So rabbet width is 5/8 of an inch. So you can start to see I've got my reference planes that I can start drawing with, but I need 2 more because again, one time looking at this drawing, I've got another dimension at the back side, which is basically the leg of the rabbet at the back side. So we want to be able to, or we could call that like the flange leg, or there's probably a good term for that. But anyway, we want to be able to change that dimension from either 1/2 inch to 1 3/16 and so on. So I'm going to make 2 more horizontal reference planes. And with each of those, I will strike a dimension to it from the outside to that horizontal reference plane. I'll select both of them. And I'm going to call this add parameter. Let's just call this the flange leg. Now it look like it might change between 1/2 inch or 1 3/16. So for right now, let's just give it a 1/2 inch dimension. I'm going to go ahead and do a save as of this family, and we want to save it somewhere where we're working. So I'm going to go to Revit workspace for now. I'll go to my family section, and I'll call this profile hollow metal door frame. We'll just leave it at that. Now what we want to do is go ahead and make, using create, I'm going to draw with lines, and we'll keep this as profile lines. That's pretty much our only option. But I'm going to hit pick lines, and I'm going to pick all these lines, or the reference planes. If I can kind of imagine myself drawing this profile, kind of sketching it, connecting the dots, and I want to be able to lock each of these lines as I draw them. I'm going to use the split line command because there are a few that need to be split, like this one off to the left and the one kind of in the middle. And I can use my trim and extend to corner, and I can start to go around and try to make this profile. In this last one, I'll use the line command, and I will align and then pick that point. I'll do it again on this other one. So I'm going to do a line. I'm going to go to that leg, flange leg reference plane, and make sure that I lock those. I also want to double check that I still have my lines locked. So I'm going to go to align, make sure I hover over any of these lines, and if one is able to be selected, then we still need to lock it. That usually happens when we split a line. So usually with the split, there's one that isn't locked anymore. So just to verify real quick, if I were to change the frame depth to 7 inches, all of my lines there should move. If I were to change my rabbit width, that moves okay, but I'll change it back. We always want to experiment first to make sure everything's working. Change my rabbit depth. So that works, but I'll change it back to 1 15/16. And lastly, the frame width. Change that to 4 inches, make sure that changes. Now I change that to 4 inches because there are times when the head of your hollow metal frame, depending on what kind of construction it goes into, it might end up being a 4-inch frame, or it might be what's most common, a 2-inch frame. Now because this is a profile, we need this to be a completely closed shape. So essentially what we need to do is take all of these lines and give it a thickness, which would be to offset them. We might give it an offset of, we'll look at 1/8 inch to see if that works, but then we'll also have to lock that 1/8 inch dimension all the way around. So if I go to offset, options bar, I'll go to type in 1/8 inch. Looks about right. I'm going to copy all of these 1/8 inch lines towards the interior just to give us a thickness. And we want to trim and extend all of these lines together. And then we want to close the shape. So I'm probably going to want to pick lines, click that reference plane and lock it. Do the same thing with the flange leg on the other side and lock it. And then close the shape with our trim and extend. Now all of those 1/8 inch offsets in order for this profile to continue to move, it's always good to take a dimension string, and I'm going to make a dimension for each one and lock it. This will just ensure that wherever the main, official lines that were locked to reference planes move to, the ones that are offset also move in the same amount of direction. So I select my dimensions. I want to make sure I've been locking them. We should just have to do one more here. So you can go ahead and hit save on that, and we now have a profile. As long as it's a completely closed profile and everything's locked and moving together with all these parametric dimensions, we'll be able to adapt this to either be within the gypsum wall enclosure or a masonry opening. So we want to make sure we hit save on this, and I'm going to keep this open in the background. Now that we have the profile made, we want to be able to bring it into a Revit door template. So I'm going to go to View, User Interface, Recent Files, and we can go to Families and New, and then we can pick Door as our template. Now in a door template, all we're going to be presented with is they've got some frame components in here. We're going to delete those. Because those don't represent anything we're doing at the moment. I'm going to also change the scale of this plan to something a little bit bigger, like 3 inches equals a foot. In this template, we're also going to go to the Family Types dialog box, and I'm going to delete this frame projection exterior by hitting remove, the frame projection interior remove, and also the frame width, because we're going to be adding in our own parameters based on what we just made. Also looking at this door family, if you look in the template, if you look at the exterior elevation, this one I also changed the scale to 1.5 inches equals a foot. But essentially the door family is an opening in a wall. So if I tabbed over one time, I have a sketch here. If I were to edit that sketch, it's just representing the void that's going to be cut through that wall. The door width and the height, that is supposed to be representing the actual door panel itself. So eventually we're going to have to do some modifications here because our door family also has to incorporate the frame. So if I look at this elevation view, I'm going to go ahead and go to switch windows and go back to my profile hollow metal frame that we just made and click load into project. Before we do anything with this profile, we look at our project browser off to the right, and under Families, I'm going to expand that and also expand Profiles. Furthermore, expand the Profile Hollow Metal Door Frame. And if we double left click in that, we now get all of our parameters that we set up and the ability to eventually transfer all of these parameters into this template. Because we're bringing in a profile family and we've embedded it within this door family, we have to transfer those parameters so we can use them. So what I'm going to do is, next to each one of these, if I click on the button off to the right, I'm going to add a parameter and I'm going to name it the same exact thing. So I'll say Revit width and click OK. Do the same thing with the next one down, add a parameter, call that Revit depth. We can do frame depth. Now with the frame depth, I'm actually going to make this, out of all the other parameters, I'm going to make this one an instance parameter. And the reason for that is the frame depth is eventually going to be based on whatever the wall thickness is. So we want that door family or that parameter to adapt based on wherever it gets inserted. Next one is the frame leg. I'll go ahead and make that parameter, and the last one is face frame width. Add parameter face frame width. So now that we have those set, so basically now if we go to our family types dialog box off to the left here, you'll see here we've got all those parameters now that are associated with this door family essentially now. So if I look at an exterior elevation, I'm going to go ahead and place one of these frames and then get it to parametrically do what it needs to do. If I go to create and sweep, I'm going to hit sketch path in order to make the extrusion length or line. So I'll do pick lines, and I'm going to pick one of these reference planes off to the left at this moment. And I'm going to lock that. I'm also going to use the line tool. I'm going to align the reference plane and the dot or the end point of that line, the sketch line, and then lock it. Click align again. I'll do the same thing at the bottom and then lock it. Now while we're in here, I'm just going to go to material and finishes off to the left here and also give that a parameter so that eventually we can call this frame material. And if I make it an instance parameter, we can, from every door that we place, we could give it a different color if we wanted to. But essentially we have this ability now by adding that parameter to make a material that could be applied to that frame. I'm going to hit the checkbox at the top, and then off to the top right where it says sweep and it has select profile, on the pull down menu I'm going to select the profile hollow metal door frame. And I'm just going to click the checkbox. Let's look at it in plan so that we can see exactly what's happening. So essentially this hollow metal door frame is actually positioned where it needs to be. Eventually we need to change the opening cut, but I need to adjust it so that right now it's being placed by the center line of the wall, and I eventually need it to move and also adjust to whatever the wall thickness might be, depending on if we're using a chipboard assembly or a masonry assembly. So to do that, I'm going to strike a dimension, and I'm going to tab over this wall that's in this family, tab over this other one, so I get basically the outside and outside dimension of the wall that's part of this family. Now again, this wall is just a default component that's within this template. When it comes into the project environment, it'll adapt to whatever wall type it's being placed into. So if I click on this dimension, I'm going to add a dimension, add a parameter. I'm going to make this an instance and also a reporting dimension so that I can report what the wall thickness is every time I bring in a door into a different wall type. So I'm going to call this wall, we'll call it wall depth, and then make sure it's instance and reporting parameter. We'll click OK. So now, since this door frame is being placed by the center line of that wall, a couple of things when we click on that parameter or the profile, if you look to the left, there's a horizontal profile offset. If I were to change that to like 1 foot, you see how it moves to the right. I have a vertical offset. It's vertical kind of in this view. So if I change that to 1 foot, you can see how that moves. So eventually we need to tie those to the wall. And I also have a rotation angle. Right now, this particular profile is facing the wrong way. I could do two things. I could either type in 180 degrees on the angle, I could undo that, or I could click on this button and hit flip, and that would also flip it. But it's also flipping it into the opening, which eventually we want it to move out of the opening, but that's okay, we can make that adjustment. So the first thing would be we want this door frame to move out of the overall width of the door panel. So in order for that to move and be in the right location, we want it to move the frame or face width that was associated with that particular door frame. So I'm going to use the horizontal offset. I'm going to click on that button. I'm going to change this to the frame or the face frame width and click OK, and that will move that frame exactly where we want it. Now this little rabbit depth, that will be part of the opening. Now the other part is we want to be able to size this frame in the depth based on the wall assembly, because if you remember from if you remember from this drawing, sometimes this frame is the exact width of the wall or the depth of the wall, and sometimes it's actually overhanging depending on the wall assembly. So I'm going to add in a couple options here for how we can make this adjust and also be positioned right. First of all, the vertical offset, let's give that a parameter. I'm going to add that, and I'm going to call this frame profile vertical offset. We probably want to make that an instance because it's going to reference the overall wall thickness, which is already, I keep saying thickness and depth back and forth. Anyway, the wall depth is an instance parameter, so we want this one to be an instance parameter because we're going to connect to that eventually through a formula. The other component here is we'll be able to adjust that frame depth in a little bit. I'm going to do a file save as real quick, and we should call this door hollow metal frame we'll say adjustable swings as far as our 3D swing and our 2D swing eventually. So with that already set up with those parameters, we can go ahead and do a couple things by going to the you can either get it into it by create or in our modify toolbar. We want to go to family types dialog box, and we want to play around with that vertical offset and also the overall width of that or depth, depth, width, thickness, whatever of that overall door frame. So I'm going to go to add parameters, and I'm going to add a parameter here that is a type parameter called yes no. Now this yes no parameter is going to tell us whether or not we want this to be either a masonry opening or a gypboard opening. So I'm going to call this parameter is masonry opening, and we'll make that a type, and we'll click OK. Now with the masonry opening, if it's masonry, which means it's, this box is checked, we want the overall width of this door to be the the depth of the wall. So here's the wall depth, which was our reporting parameter at 6 inches. So what I can do is, with the frame depth in the formula bar, the easiest thing at the moment before dealing with all the toggles I'm going to introduce is my frame depth in the formula bar could equal the wall depth. That's if this is going to be a masonry opening. You can see here when I hit apply that adjusted. And then our frame profile vertical offset, since it's being put in at the midpoint of the wall, and I could have adjusted this profile and made it where it grew about the center line, but I didn't, so I'm going to make an adjustment here where I say that this is the wall depth divided by 2 and hit apply, and I see that it's moving in the wrong direction, so I'll put that in parentheses and put a negative in front of it. So you can see I get that frame in there. Obviously we still have to adjust the opening, but that'll be something in a little bit here. Now, so what I'm going to do is, while I'm sitting here, I'm going to do the family types and then click new, and I'm going to call this masonry door frame. And then I'm going to click new, and I'm going to call this other one gypsum board frame, or we can say gypsum wallboard Now with the gypsum wallboard frame, I'm going to uncheck the masonry opening. It still doesn't do anything because we haven't programmed it. But in the formula bar up here, with the frame depth, I'm going to make the frame depth have a conditional statement. I'm going to say if parentheses is masonry opening, comma, then make the whole depth of the frame the wall depth. So make it flush out. Comma, if not, which means if it is a gypsum wallboard assembly, I'm going to make it the wall depth plus, in parentheses, 2 times the frame leg. Because essentially, even though in these documents that I'm showing you, this is saying 1 3/16 of an inch, or this is saying 1/2 inch, depending on where it's being applied, we want this frame leg dimension, whatever it might be, times 2 to make up the overall frame depth. So if I were to hit another parentheses on that, hit enter, I can click apply, and then we'll have to do another conditional statement up here with the frame profile vertical offset. So first of all, with this toggle, if I were to change this from the masonry door frame and hit apply, you can see how that changed. Go back to gypsum wallboard assembly, and that also changes. Now the only thing we need to do with the frame profile vertical offset is to give it a conditional statement so it adjusts accordingly as well. So in this formula bar, I can say if is masonry opening, comma, put all this in parentheses, the negative wall depth divided by 2 is what we want. Comma, if it's not, if it's in the gypsum wall assembly, we need to add in parentheses, negative, parentheses, wall depth, plus, in parentheses, 2 times the frame leg. So basically we're copying the same exact formulas that are part of the frame depth. So actually, I think I could simplify this. If is masonry opening, we may not even have to do that. To say negative, in parentheses, frame depth divided by 2. I don't think that's going to work. Oh, it did. So if I change it back to the masonry, there we go. So actually that was a lot easier. I was going somewhere in another direction. Anyway, so if we have our frame profile vertical offset is just negative the frame depth because it's being controlled by this conditional statement that we already set up with the frame depth, we're able to get this profile, as you can see when we change it from masonry door frame to gypsum door frame, to adjust. Now with the gypsum wallboard door frame, if you remember looking back just at these drawings as an example, the gypsum board is referencing profile B, and it says that that leg is 1 3/16 of an inch. So in my frame leg, I'm going to change this under the gypsum wallboard frame family, change that to 1, what was it? 3/16. So you can see there we can hit apply, which seems a little bit deep to me. Typically in our office we've always done everything 1/2 inch. So, but we'll keep it at that for now. I can change this now back to masonry, hit apply. You can see how that frame continuously keeps to change. Go ahead and hit save on that, and what we need to do is set up this frame on the other side, and then also at the head condition, and then join them together. So to work on the other part of the door frames, I'm going to go back to an exterior elevation, and I'm going to click on Sweep, Sketch Path, and we'll go back to here to pick lines. I'm going to pick the other vertical right side, click on the padlock, and use a line, and I'm going to align the top reference plane and the end point of that line and lock it, and do the same thing with the bottom and lock it. Again, we can give that a material parameter. I clicked on that little button off to the left of material, and since we already set up frame material, we'll go ahead and click OK. Hit the checkbox, and then we'll select our hollow metal door frame and hit checkbox. Now let's look at it in plan, make sure this one is in the correct location, and it isn't, as our other one was not as well. We don't have to rotate this one, but I'm going to use my horizontal profile offset. If I click on the face frame width, it's going to move it out off to the right. So what that means is I actually need a face frame width negative number so that I can move this over. And I'll click OK on that. Now if I go to my family types dialog box, and where I had the face frame width negative, I'm just going to make that in the formula bar negative face frame width. That'll move that door frame into the correct location. Now I can pick that profile again, and with the vertical profile offset, we should just be able to pick the same exact parameter and click OK. So now we've got both of the jam details. Again, we will adjust the opening correctly in a little bit, but you should be able to look at your family types dialog box and switch between masonry and gypsum wallboard and hit apply, and you can see how that door frame is changing. I gotta be honest, I don't like the frame leg at 1 3/16. I know they kept it that way to keep all the frames the same. I think that's why they did it, but we typically do 1/2 inch. That looks a little more normal. So last thing is we need to deal with the head profile. So I'm going to look at a left elevation, and we'll also go back to an exterior elevation. And this one I'm going to create a sweep, and this time I'm going to make a sweep again with the sketch path, pick lines, and I'm going to choose that horizontal top reference plane and lock it, and then align each of these. And actually, by doing that, we need to cancel out of that command real quick. I need to create a couple more reference planes. I'm going to create one vertical to the left, another one vertical to the right. I'm going to give that a dimension from each of those reference planes, and I'm going to call both of those with the label up here, face frame width. I just need those as an end destination of what I'm about to draw with this sweep. So I'm going to hit create, sweep, sketch path, pick lines, and then pick that horizontal line at the top and lock it, and use my aligned dimension or line command and pick the endpoints. So align from that reference plane we just made to the endpoint of the sketch. I basically eventually need these frames, they're going to overlap and we can join them. Again, I'm going to give this a material by clicking on the material and finishes and click on the button. I already have a frame material parameter entered in, so I can select that. I'll hit the checkbox, and then with my profile up to the right, choose profile hollow metal door frame and hit the checkbox. I'm going to look at that in a left elevation because it's probably not in the right location at all. and I probably want to just flip this, and then I'm going to give it a horizontal dimension. Let me check. So my horizontal, when we're kind of in this view, it's a little bit backwards. Our horizontal actually moves this up and down, and our vertical is going to move it, you know, back and forth. So our vertical offset, we can make that equal again to the face or the frame profile vertical offset. That moves it into place. And I need my horizontal profile offset to move up the face frame width. So that gets that in the correct location as well. The last thing we have to deal with is the opening cut. Right now, if this was a gypboard wall assembly, which we're showing right now, typically your rough-in gap is 1 inch from the overall opening of the door. And so you would have another gap here that goes 1 inch over in the frame. And if this was, if I go back to my family types dialog box and hit masonry door frame and OK, when it's a masonry door frame, the opening gap is actually going to be, you could either do it right up against the frame, or typically in the detail, you know, if you look back at what we have here, you're going to have an additional 3/8 of an inch that's going to have a joint for your sealant and backer rod. So we want to be able to program all that in. I'm going to go ahead and hit save on this, and then we'll go ahead and program that offset for the roughing gap for whether it's a masonry or a gypsum wallboard assembly. But if we look at our left elevation, our frame should still look correct up there. One thing I do want to do with this frame that's up at the top, right now we're referencing the profile frame. I want to duplicate this just for the head. So over in my project browser, I'm going to go to duplicate. I'm going to call this hollow metal door frame underscore head. And the reason for that is sometimes your head has a different dimension than your jambs. Your head might have a 4-inch, your jambs might have a 2-inch face frame. So with my hollow metal door frame head, if I double left click on it, I have to reset all of these parameters because we just duplicated it. But I'm going to make my rabbet width, click on that button, equal to the rabbet width here. Rabbet depth, the same thing. Rabbet depth. My frame depth, also frame depth. Frame leg, we will also do that as the frame leg. And here with the frame or the face frame width, I'm going to click on that, and this time I'm going to click add parameter. I'm going to call this face frame width head. This way, this will give me options to eventually, which I'm not going to do at this moment, but eventually you'll have the option here to change. If I were to go to my family types dialog box, I could say face frame width head. If I were to change that to 4 inches, click apply. Well, that was supposed to change. Oh, so I also have to click this profile. I forgot to do that. And over here where I'm referencing a profile, I need to change that to reference the hollow metal door frame head profile. And it's going to cause me to also adjust the vertical offset or the horizontal offset. So we'll make that the face frame head. And that'll adjust that correctly. So sometimes you have a 4-inch head because you want to have all your doors at 7 foot high and it's being put into a masonry opening, so usually you end up with a 4-inch head to make it course out. Sometimes you might customize your door to be 7'2", and then you can keep all your frames at 2 inches. So anyway, I have this ability to change that door head height with that parameter. So now that we have the frame made, we just need to work on that rough-in gap. So what I'm going to do is look at an exterior elevation. And what we want to do is a couple things here. Is we want to be able to take the opening that's dealing with basically what's going to be cut through the wall, and we want that to adjust basically if it's a masonry opening versus if it's just a gypboard enclosure. So I'm going to make a parameter. I'm going to add parameter and call it rough in gap jam, and we'll make the same thing but as the head. So we'll say rough in gap head. Now the jam and the head, it's all going to be based on, again, this toggle, the if is masonry opening conditional statement. So with the jam, we're going to type in the formula bar if is masonry opening. Then we want the actual opening to become basically an additional face frame width. If it's not masonry opening, then we just want it to be 1 inch. I'm going to do the same thing with the head, but this time we'll say if parentheses is masonry opening, then we want the face frame width head. Otherwise, again, we just want 1 inch and hit parentheses. So when we change from gypsum to masonry, our rough-in gap should be changing up here. You see where that changed from 2 inch to 1 inch as I switch back and forth. And then we want to actually make this parameter so that we can attach the opening cut to this. So I'm going to hit create, and I'm going to do a reference plane. And I'm just going to do a vertical reference plane to the left, another one to the right, and I'll do one horizontal to the top. The horizontal to the top, I'll make a dimension string that's from the top of the door up to that wherever that horizontal plane might have been. And I'm going to turn that dimension into the rough-in gap head. I'm going to do the same thing with the other two sides. I'm going from the inside, basically where the door panel is supposed to be, and then the vertical on both sides. Now both of these will be the jam, so I can select both of these and click on rough-in gap jam. And for right now I'm going to change my door into a gypsum wallboard frame just so I get those reference planes to only be 1 inch away, so eventually I can snap this opening cut to it a little bit better. So I'm going to hit save on that. So next, if you hover over kind of the outside boundary of where the door is supposed to be, I'm going to tab over a couple times until over in the bottom left hand corner you should start seeing a note that eventually says opening cut, opening cut. Now I'm going to click on that and then click edit sketch. Basically this gives me the sketch of the void, and what I want to do is use the align tool. I'm going to align it to those new reference planes that we just created that are going to represent that rough-in gap. I'm going to do that all the way around, and I'm going to remove the constraints, and then I'm going to lock the padlock. And I'll do that on all 3 sides. And when I click the checkbox, what I end up having when I look in plan, you can see here if this was a gypboard wall enclosure, that's exactly what you'd expect to see, a 1 inch gap, and then your frame sort of hugging the wall. And if I were to change this to the masonry opening and click apply, you can see there now I have the frame and it's actually butting up against the gap or the masonry opening. Now the masonry opening also has a 3/8 inch gap usually, so that you can have sealant and backer rod in it. We could get that specific if we wanted to, and if we wanted to do that we could go to our family types, and where it says this is masonry opening, we'll do the face frame width, and I'll just add plus 3/8 of an inch. And I'll do that on both of those. And now when I look at that door, I have that that frame set up. So the last part with the frame is if we look at this in 3D, I'm going to turn on a shaded view. We've got a jamb and we have a head, and you can see there we've kind of got a line there that's showing where all the different parts and pieces were coming together. Under Modify, I can hit the Join tool and then just join these together, and that'll get rid of that line. So what we have left to make is now the door panel. So we've got a couple different options for that, and also the 2D door swing that will also go into this family type. So I'm going to hit save on that, and then we'll go ahead and make those other two parts and put it all together, and then we'll have our operable door that's fully parametric and has all of those 2D components associated with it. Now again, I've got a masonry door frame and a gypsum wallboard frame assembly that are programmed directly into this door family at the moment. So now we want to be able to make the door panels. We'll start off with the solid panel and then work our way to the one that has different sizes of glass basically in it. So back in Revit, what we want to do is we can keep this file open. I'm going to go to View, User Interface, Recent Files, and let's go ahead and open up a new, in this case we will do a new generic model. Generic model templates are great for starting something that doesn't have a wall in it. Usually if we do like the door template, we're always going to have a wall hosted within this. Once we do a generic model, we can go up here to the very top, and where it says Family Categories and Parameters, I can click on that. I can change this to be a door. So all I did was select door. I ignored that pop-up window that came up and clicked OK. So in the front elevation, I'm going to just use this as a drawing plane to start making our door panel. And so the very first one, which is a solid door, is actually very simple. I'm going to do a reference plane. I'll make it horizontal. Then a vertical one off to the right. We can give it 2 dimensions, and the one that's horizontal, we'll use the label and add a parameter. You can see here that because we turn this into a door family, it already now came with a width and height and other parameters that are associated with doors. So we actually don't have to make any new parameters. I can just assign this dimension, the horizontal, by using the options bar, pulling down the label, and I'll select width. The other one, I'll do the same thing and select height. And in our family types dialog box, let's make this kind of a normal door for now as a default. So 7 foot high by 3 foot, which is probably the most typical door out there. Then what we want to do is create an extrusion. So I'm going to stay in this view and hit create extrusion. And I'm going to use pick lines. I'm going to pick all of the reference planes, and I want to lock my lines to them. And then trim and extend by clicking on the parts that you want to keep. And then we can go ahead and click the checkbox. Now if I look at this in plan, this is going to be a big extrusion. Basically it extruded down by default of 1 foot. I'm going to do a couple things off to the left here where it says materials. I'm going to click on that little button there, and I'm going to call this door panel material. We can make that an instance and click OK. And then we've got an extrusion start and an extrusion end. The extrusion end wants to be equal to, so if I click that button next to it, equal to the thickness of the door. This way now I can change it with my family types dialog box, and I can change the thickness to a typical door, which is 1.75 inches or 1 3/4. So that in itself is, you know, a very simple way of making a door panel. I'm going to go ahead and do File, Save As, Family, and we want to go ahead and save this as a, let me get my right spot here. We'll call this a door, we'll call this solid flush 3D panel. Give it some kind of description. Now with a door family, basically I'm going to bring this into the next model, but I want to make a couple other door panels before we start, you know, bringing it into the main door family and then also dealing with the 2D door swing. So I'm going to go back to the front elevation here. I'm going to do a File, Save As of this, and we can call this door solid flush 3D panel, and let's call this with we'll say with half light. Half light will represent this door panel number C, or letter C, which basically has a glass panel that's up at the top portion. And then we'll do this other one that's going to be kind of more what's called a stile and rail door. Stiles are the verticals and rails are the horizontals. We can make that another panel type as well. So in this one we're going to have basically a void and then another extrusion that's going to be the glass within it. So we can actually set this up, this glass door or this door panel can actually have a couple different family types in it. So we could actually do the stile and rail door, and we could actually do the half light. But we'll just do it as one file and then the other for now. So what I'm going to do is create a couple more reference planes. I'm going to do a vertical, 2 verticals on either side, and 2 horizontals. You know, something that's going to represent what we'll eventually cut out. I'm going to do a dimension horizontally from the reference planes, and then the vertical dimensions to the horizontal reference planes. And I'm going to call the one on the left, let's go ahead and add a parameter, and I'm going to call this one, let's just call it side stile left width. Do the next one, we can add a parameter. I'll call this side stile right width. And then we want the top, and this would be counted as a rail, so I'll call this top rail, we can call it height, or we can call it width as well, that's fine. And then this other one down below, we will call that, even though in this door panel it's really kind of the bottom panel, let's just call that the bottom rail width. And then if we look at this drawing, we can see that we've got the bottom glass goes to 3 feet. We have 9.5 inches on either side, and then 14 inches at the top. So I will go into the Family Types dialog box, and we can say the top rail width is the 14 inches. These right and left stiles are 9.5 inches. And then that bottom is 3 feet. So that'll get that, that panel. And what we want to do is click on our extrusion. So if I click on that and click Edit Extrusion, I can now click on Pick Lines and pick all of those reference planes. And because we're kind of making this square or a rectangle inscribed within a door panel or an extrusion, it will now become a void. And now we can add the glass material. So I'll create another extrusion, And we can select by tabbing over a number, probably like 3 times. You can select all of the inside parts of that void at once, and then we can go ahead and lock all of those components. Now I'm going to make this material. I'm going to add a parameter here and call this glass material. We can make that an instance. And then the extrusion start and end, we're going to go ahead and give that 2 parameters. I'm going to make that button and add, and I'll call this glass start. And the other one, we can add a parameter and call that glass end. Now the reason for that is we're going to center this glass within the door panel, and what we need to do is come up with a little bit of a formula to make that always work. So I hit the checkbox, and in my Family Types dialog box I'm going to go ahead and set the glass material. I'm going to click on it, and just by default I'm going to select glass in the materials dialog box that pops up. So you can see here, right now we've got the glass, but it's extruding obviously by default of 1 foot. So to get that centered, what I'm going to do is give this a little bit of a formula. We want to first make a parameter in our Family Types dialog box by clicking Add on Parameters, and I'm going to click Glass Thickness as the new parameter. Now the reason for this is sometimes your glass is 1 inch if it's used as an exterior door, and sometimes it might be just a 1/4 inch if it's an interior door. So what we can do, we'll just make this a 1/4 inch for now. We can now make our extrusion start, our glass start and glass end, a little bit of a formula here. To get this centered, we need the overall thickness of the door, and I'm going to divide that by, I'm going to subtract actually the glass thickness, put that in parentheses, and that will basically give us the remaining amount in the door, and if I divide that by 2, that should give me the start of where that glass should be. If I hit apply, that'll put that at that location. Now to get the glass end, I'm going to say basically all we need to do is the glass start plus the glass thickness, and that should give us our 1/4 inch glass that's right there centered in the middle. You can see that off to the left. I can check this by changing this to a 1 inch piece of glass and click apply, and you can see how that glass extrusion changes and it's still centered. So we've now made that door type. I can go ahead and click save on that, and then we can just make the other one. And I could actually do it in this family. We could, now let's go ahead and do that because that's what this is set up for. Even though I named this file Door Solid Flush 3D Panel with Half Light, I might rename that file. So I'm going to do a file Save As Family, and we should call this Solid Flush 3D Panel. Let's just call it with glass, because then it gives us more options. So what I can do is, since I've made this door, I'm going to click on this and say New Family Type. And I'll call this a half-light door. And then to make the other door type, if I look back here, I've got a style and rail door that's basically the same kind of configuration, except there's just more glass. So it looks like at the top, it's hard to tell, but I think it's 5 inches all the way around, and then 7.5 at the bottom. So we can just make a new, in my Family Types dialog box, just click New under Family Types, and I'm going to call this one Style and Rail, and we will call the side lights will be 5 inches, each of those, the bottom rail width was 7.5 and the top rail was 5 inches. We hit apply. We now have made, just by changing parameters, the style and rail door as well. So those are our two 3D panels that we're going to use for the moment. There's actually three, but two files that we're using. And I can go ahead and load this into my door family project, and it's going to want me to place it. I'm just going to hit escape or just the modify. And I'm also going to go back and I want to load up, so I'm going to go to recent files, my solid door. I'm going to load this into the project. Of course it wants to place it again, we'll just ignore that for now. So now that we have the door panels loaded in, let's go ahead and set it up so that they can relate to a reference plane that actually rotates. So if we go to a floor plan, and if I look at our door family that we've set up so far, what we want to do is create another reference plane. I'm going to create it above horizontally of this in this view. I'm going to strike a dimension from the center of the wall, and I want to make sure I'm selecting the center of the wall to that reference plane. And you know you're selecting the center of the wall when you see that blue dashed line instead of selecting the green one. Now just move that dimension off to the side. Now this dimension wants to be a new dimension called, or a new parameter. We'll just call this face of frame. We'll make it an instance. And with our family types dialog box, the face of frame parameter that we just made, we want this to be, and if you remember, our frame profile vertical offset is actually the frame depth divided by 2, and it's a negative number. We want the same thing, or we could just say ABS for absolute value in parentheses, and we can say frame profile vertical offset. That'll give us a positive value that we can assign to that. Basically what this does is make it so that this reference plane is always at the face of that hollow metal frame. Now you'd think we could just lock it to it, but locking things to objects usually results in any kind of constraints not satisfied, errors, and things like that. So the next step is I'm going to hit create reference line, and I'm going to make this reference line from the corner of that hollow metal frame, and I'm just going to draw it out in some fashion. What we want to do is align. I'm going to align to this vertical, and I'm going to tab over till I get the dot of that reference plane. I'm going to do the same thing with this horizontal that we just made, and tab over and get the dot or the end point. Once we have that locked, we can select this reference line, and I can click the dimension icon. It basically turns that temporary dimension into a real dimension that we can then also change to be the width of the door. It's going to rotate a little bit, that's okay. Next step is to use our angular dimensions. I'm going to angle my dimension from that reference plane to the reference line, and we can make that into a parameter by selecting that angle dimension and going to add parameter, and we'll call this 3D door swing, and we'll make it an instance. We should be able to check our work by changing, let's say, the width of the door to 4 feet. Looks like everything moved correctly, and then we could change our 3D door swing. Let me give it a 45 degree, and our reference line should rotate. I'm going to change the width back to 3 feet, which is a more common door size. So now that we have this reference plane or reference line, the door panels that we've brought in, so we've got all these, we've got the door solid flush panel and we have the one that's a half light and a style and rail. If I'm expanding over here on the right with my families, a couple things we want to do is I'm going to double left click on where it says door solid flush 3D panel, and we've got a few parameters here that have some buttons that basically we need to pass into this family type. So the width, I'm going to click the button and I want that equal to the width of the parameter that's in the family. Same with thickness. Might want to double check something. Go back to our family types. Let's make sure our thickness has a dimension to it. I'm going to type in 1.75 inches. If we didn't do that, we'd get an error that it couldn't make the door because it would have gone from 1 3/4 to 0. So now I can select thickness, and the other one is height. I think that's it for now, and we can go ahead and click OK. We want to do that with the half light. This one has, remember, a few more parameters that we're probably going to have to pass and also make part of this door family. So I'm going to go to width, top rail width. We don't have that one here, so I'm going to do add parameter. I'll say top rail width. We'll keep that as a type. Thickness we have, so we can select that one. Side style right and left we don't have, so I can add a parameter. I can say side style right width. Side style left width, we need to add a parameter. We have the height, and we need a glass thickness. And then we've got a bottom rail width that we'll also add in there. And starting to think about it, don't really need to, I guess I could do the same thing with the style and rail, but actually all of these parameters, since they're being passed into the door family, we can set the style and rail door up as a set of parameters. So we'll just place the half light. Maybe let's delete the style and rail out of there and rename the half light. We can just call this back to the door solid flush 3D panel with glass. I was thinking earlier on that we might need the extra one, but now that I think about it, I think we'll be good with just these two styles. So what we want to do is place one of these doors, and I'm going to click Create and Component. I'm going to pick the one here that says Door Solid Flush Panel, and before I place it, just realize we need another step back here on our door family. I'm going to right click where it says Door Solid Flush Panel, click Edit. That'll bring me back into this panel, and over here to the left I forgot that we need to set this as a workplane based family, and hit Save and load back into the project and overwrite. And do the same thing with the door solid panel with glass. Right click on it, tell it to edit. I'm just going to delete these names that I have up here. I was going to bring that in. Shoot. There we go. Delete. I'm just deleting the names, the half style and style and rail, because I still had to open it. Brought back the the other one that I already made. Anyway, workplane base, I want to check that. Hit save, and then I'm going to load this into the project and overwrite. What that allows me to do now is when I hit create and component, I can now choose to place on a workplane, and then I can choose in the options bar where it says placement plane, I can choose pick, and I want to pick a plane, and if I hover over this door, or not the door but the reference line, and click, I'm now placing it on that plane. I'll just place it around there, and I'm going to align it and lock it, and tab over till I get the end point and align and lock. And if I look at that correctly, do two things. I'm going to change the door swing, just make sure that rotates, and it says constraints not satisfied. Great. So I need to do a couple more things here. If I go back to my door families, right click and click edit. Also, when we checked workplane based, I also need to check always vertical and uncheck that. So I'm going to do that with both of those door panels and load it in. Door solid flush with glass, right click on it and say edit, and this will be workplane based only, and always vertical is unchecked. By doing that, and I load it in and overwrite, if I hit create and component and I place this door, so I've got the door solid flush 3D panel, I'm going to click work plane or place on work plane, and I'm going to choose placement plane and pick. Choose pick a plane, and then that reference line again. Now when I align it, this time I'm going to align the door panel. I'm not going to lock it. If I test this out and change the rotation, you can see how the door panel is moving with the actual reference line. For some reason, by locking it, it creates a constraint error. So if I were to align and lock, actually it doesn't do that anymore anyway. So actually you could lock it. It's probably a good practice. Now the other part is we need to figure out which side is going to allow us to lock to the end of this reference line. So I'm going to do an aligned command. I'm going to try this first one off to the left. I'm going to tab over till I get the end point, and then I'm going to pick and lock. Now let's make sure when I change the degrees I still get an error message. So now I'm going to try to align and lock the other side. So looks like the end on the right side is the end that's going to work. So we now have a door family. We've got the frame, we've got the solid panel in there, and when we change the swing, we can get it to open and we can get it to close. Open to any degrees that we want, so that we could have the ability to change this for future like if you're doing a rendering or something and you want to open the door in your model. Now typically in a floor plan we don't see the 3D swing, so I'm going to click on that, and I'm going to also make that if I go to my visibility settings, I'm going to uncheck to see that in plan, reflect to ceiling plan, and actually we only want to see it display in 3D views end, and then it says plan RCP. We don't want to see it in the, we do want to see it in the front, back, and left, right. Okay, so we want all that. Click OK. Now I can click on this door, and over here where it says door panel material, I want to click on that and make that equal to, we need to add a parameter called door panel material. And then with this door panel, we can actually select it, and I'm going to choose under the label here where it says options, I'm going to add a parameter, and this is going to be a family type parameter that I can actually change out this door panel. So I'm going to say door panel type for the for this parameter. So what that does, looking at it in 3D, is I can now set up where I have my couple different door types. So we've already done the frames. So we've got a gypsum wallboard frame, we've got a masonry door frame. What we'd want to do is with the gypsum wallboard frame, I'm going to rename it. I'm going to do some underscores, and I'm going to call this one, let's say, solid flush underscore, and we'll call this one 3 foot by 7 foot. Give it an actual name. And so if this is going to be a solid flush door, everything that I've already set up is correct. So I'll click apply. And let's say I want a gypsum wallboard frame with one of the half light. I'm going to do new, I'll say gypsum, actually it'd be easier to click rename, hit Control C, get all that text, then hit cancel, then do new, Control V, and then I'm going to say this is solid flush with half light, 3 foot by 7 foot, and then all I have to do is come down to the bottom here, and where it says door panel type, I can click on the down arrow and I can select the one for glass. I'm going to hit apply. Of course. So it switches out, but my constraints are still not satisfied. So I just realized maybe the locking the end doesn't quite work, because if I just move this panel down to where it's supposed to be, I didn't have to lock it because it's attached to that reference line. And if I change the angle and also change my from solid flush to the solid flush from the glass, it seems to work correctly. Revit's so finicky about these constraints. So I've got that panel. It's rotating, and I'm going to look at what happens when I change it to a masonry door frame. Can't make the door because I probably have the masonry door frame, I didn't set up a thickness for it. So now when I hit apply, you can see how that door panel is now working. So I could do the same thing with the masonry door frame. I could set up a solid flush with half light, 3 foot by 7 foot. I could also do the same thing with a solid flush. So I'll rename this one, do underscore solid flush underscore 3 foot by 7 foot. And I can hit rename, Control C, cancel, do family types new, Control V. I'm going to say solid flush with half light. And then we can just scroll down to the bottom here and change the door panel type to be the one with glass. So we've got our door set up. The only last component we need is when you're in a floor plan, typically you don't, like I said, see the 3D or the 3D component. That's something you want to see obviously when you're doing a rendering or so on, or looking at it in 3D. So what we need to do is add in a 2D swing that will mimic with symbolic lines give us some other adjustability in our floor plan when we're just looking at the doors, kind of layout within different rooms. You want to have the ability to open and close your door swing so it looks good for your floor plan, but again, you might want to have something different for your door swings when you're looking at it in elevation or perhaps in renderings. So typically by default I make all my 3D door swings at 0, just because typically when you look at all of these options you kind of want your door to be closed so that when you're looking at an elevation you see the actual type of door that it is, and if you want to open it then you have that ability. And again, we made that 3D door swing an instance parameter, so that makes it where you have the option once it comes into your family or into your project to open and close it. Before we go into the 2D door swing, I forgot that we also had the style and rail door, so I want to show how we'll make that. And we don't have to do anything more now other than create some more family types. So up here I will do a rename, hit Control C, do family types new, Control V, and I'm going to call this one solid flush. This is not really solid anymore, is it? We'll just call that style and rail. 3 foot by 7 foot. And then we can change our parameters here. If you remember, our style right and left was 5 inches. And then our top rail was 5 inches, and our bottom rail was 7.5 inches. If I hit apply, you've got your style and rail door, and now you can also make obviously whatever glass door you want. I'm going to do a rename, Control C, do a new, Control V, and this time I'm going to change it to be masonry frame, and all we have to do is check the button is masonry opening and hit apply, and we now have that in our masonry opening. So the last thing that we need to make is the 2D door swing. So I'm going to go to View, User Interface, and Recent Files. Let's go ahead and open up a new family template, and we'll start a generic model. With the generic model open in the floor plan, I'm going to create a reference line, and we'll go ahead and just draw it off to the right at some kind of random angle. I'm also going to align and lock the endpoint to both of the vertical and the horizontal. We can select that line and then give that a real dimension by clicking on that icon, and then if I select this dimension, I'm going to add a parameter, and I'm going to call that width. Next we'll give it another parameter or dimension that's angular from the horizontal to that, and I'll give this a parameter by adding a label. I'm going to call this 2D swing. It'll probably jump to the other side, but it should, if we did everything right, be able to change our parameters to 3 foot. That changes, and our door swing, if we change it, or our reference line angle should also change. Now next we want to use the annotate toolbar, and we're going to use symbolic lines. Symbolic lines are not model lines, they're just generic lines that show up in 2D. And in this case I'm going to use a generic model projection, and I'm going to use the pick lines, and I'll pick that reference line and lock it. I'm also going to offset, let's say 1.75 inches towards the right side of this, And I'll use create, or I'm sorry, annotate symbolic line, and we want to close the ends of that door panel. And we want to set up dimensions, and it's very important now that we tab over until we find in the lower left corner it says reference lines, reference. It's kind of redundant, but that's what we want to select. And then I'm going to strike a dimension. I'll give that dimension a parameter, and we'll call that thickness. And click OK. Now we want to make sure that when we tab over that end point of the reference line, our line here should be aligned. Let's just double check. Let's make this a 4-foot width. Yep, so you can see my door panel is not moving to the end of the what would be the door width. So I'm going to use align dimensions. I'm going to select that reference line and then the end panel or line and lock it. I could probably do the same thing on the other side. I want to tab over a couple times. And then lock it. I had to tab over a couple times until I was selecting the reference line again. So if we did everything right, I should be able to type in 3 feet. My door should shrink, and I should be able to type in a new angle dimension, and everything should rotate. A couple other things, we'll create another symbolic line. I'm going to do a center ends arc command, and we will just draw from the center of the origin of this file to the end of the door panel, and then make that arc swing come all the way down. So it should grow as we change the dimension, or it should shrink, and we're able to get that door swing. So if I go to 90, I won't go to 90 for right now, I'll just go 45. Anyway, we got that working. I'm going to do a file save as. Let's call this door. We can call it 2D swing. Now, because some of our doors sometimes have glass in it, we also want to represent which doors have glazing and where it might be. But again, we're just dealing with 2D. So I'm going to do a couple of things by just offsetting. Let's just pick 5 inches for now. Kind of this end point, or the end line. I have to tab over to get that one. And I'm going to give that a dimension. And I'm going to dimension from, well, we can do from end and end. And to match up with what we've done so far with the 3D panels, I'm going to click on the dimension on the right. I'm going to add a parameter, and I'll call that side style width right. I'll call the other one side style width left. Now we want to double check things, so I'm going to change my angle dimension. Everything's rotating, and if I change this to 6 inches, just want to make sure that my side stiles are moving. And the next part is to offset 2 lines, and I'm going to do, let's do a 1/4 inch each time. And with this line, this is going to represent the glass, and we'll get it to set correctly in a minute. But I'm going to align to the inside of the style, and then I'm going to tab over and pick the end of that symbolic line. Oops, I did not get the right one. Let's do this. Let's trim it first. And then I'm going to align and hit the endpoint and lock. So it would over-constrain the sketch. Maybe we don't have to lock it. Never know when Revit's going to tell us we've over-constrained. Alright. If I change this 5 inch and 5 inch, let's just make sure things grow. So those lines actually don't need to be locked. Alright, what we do need to do is add dimensions so that we can get the glass to appear like it would if it's centered within the door. And sometimes it's a 1/4 inch piece of glass, and sometimes it's going to be a 1 inch piece of glass. So I'm going to strike a dimension, and this is going to be important that we come from tabbing over until it says reference lines, reference lines, reference. And I'm going to go to the first offset. Then I'm going to go from that offset line to the next one. I'm just going to pull a dimension off. So this first dimension, the one that was from the reference line to the first offset, I'm going to add a parameter. I'm going to call that glass start. And the other one, add parameter and call that glass end. And then we can do the same thing with our formula that we did in the 3D panel. I can click on this and say I need to add a parameter called glass thickness. And if I say this is supposed to be 1 inch for now, and then we can change it to look at it, our glass start is going to be the formula thickness minus glass thickness in parentheses. We'll divide that by 2. And then our glass end is going to be the glass start. Actually, in this case, because we went from the glass start already, the glass end will just be equal to glass thickness. So we kind of did a redundant parameter here. I click OK. You can see how that adjusted there. And if I change this back to something like an interior door, where this would be a 1/4 inch piece of glass, you can see there where it centers within that panel. So I want to test out a couple things. I want to grow the door, let's say to 4 feet. Everything moves, and if I change my door swing, everything moves correctly. So the only last thing that we need to do is, because sometimes this is going to be a solid door and sometimes it'll be a glass door, is I'm going to select all the items that would represent a glass door, which are basically the lines that I've highlighted here. And over to the left where it says visible, I'm going to click on that parameter and give it a visibility parameter called show glass door. Click OK. OK. And then now we have it where we have a toggle where we can actually change this from a glass door to a solid panel. So I'm going to hit save, and we can load this into the project. And I'm just going to place it somewhere off into outer space. And as I place this, when I select it, I'm going to click on edit type, and we're going to transfer these parameters over so that we're able to control them within this overall door. So clicking on the button width, we want that equal to the width that's here in the project. Same thing with the thickness. Side style, width, right and left, we have those parameters. So that one was right, next one is left. Glass thickness, we also have that one. Glass end, we don't need to worry about that. The 2D swing, we're going to click on that, but we don't have that as a parameter, so I'm going to add this and call it 2D door swing. And we'll make that an instance. So that should be all of our parameters that we need. Oh, and I've got this other one, show glass door. We need to click on that, and I'm going to say show 2D glass door as that parameter, and click OK. We'll eventually have to set those settings. But now if I use the line tool, I'm going to make sure I pick this reference plane that was outside the basically the face of frame parameter that we made. I'm going to select that, and then the door, and lock it. And then over to the left, kind of the inside part of the frame, and lock it. And now I have my door assembly. But what I need to do is set it so it looks correctly depending on what type of door type we have. So in my Family Types dialog box, with all those doors that we've already set up, since we've added a few more parameters here, actually only the one that says show 2D glass door, you can see here our style and rail has that checked. I'm going to go start from the top. I'm going to go to the half light. I'm going to hit apply. You can see how that changed. I'm going to go to the solid, and I'm going to uncheck the show 2D glass opening or door. Click apply. You can see how that changes to the left. I'm going to go through and make sure I set this correctly with all of the types that I've made. So this one's solid, so I'll uncheck show 2D glass door. And this one shows the glass, so I'll click apply. So now we've set up our door that is obviously very detailed, but it does a lot of things that we want it to do when we're working in Revit. And I'm going to bring this into a project family or a project environment so that we can test it out. Definitely want to hit save on this. But we've got the frames that look correct. We have the ability to change the head of the frame depending on whether it's a 4-inch or a 2-inch frame, so we gave it that ability. There's also the opportunity to open and close the door in 3D for renderings and so forth. And then also our 2D swing. If I were to change the 2D door swing, by default we'll set it to 90. You can see how we can get our typical door. That's one thing I probably want to do, is go to all these door types and set it to 90, which is what Revit starts out with, with their door type, but you're never able to change that door swing. So I'm just going through these doors, making sure the 2D swing, just by default when it comes in, is going to be at 90 degrees. So I'll hit save, and if I go to View, User Interface, Recent Files, I go ahead and open up an architectural template. Now I'll make a wall, just any generic wall, and then I'll take this door and close out of the 2D door swing, put the door type we just made and load it into the project, and then I can place it. So in this case I placed a door type that is in a masonry opening. I can now, over to the left, change it to my solid gypboard with kind of the half light there. I can do the solid, and I have the ability here for each door that I place to change the door swing in 3D and in 2D. Don't change it to 0 on the 2D. You'll never typically show a 2D door swing at 0. The reason it gives me that error saying it can't make the door type is if the 2D swing is at 0, this arc eventually goes away, which means Revit doesn't know how to deal with deleting a line that was already in the family. So that's why I got the error message. Also, there is a little bit of a workaround with that. If you wanted to, you could extend this arc a little bit further down, and then it wouldn't ever go to basically 0. Looking at this in 3D, I'm going to just close out by copying this door. I think we made 6 types, so I'm going to copy this, 6 times. Could have arrayed it, but look at it in 3D. I'll go ahead and make each one different types. So I can start with the first one. I'll make it the first one that we made. A solid. The style and rail. Masonry one. Masonry solid. Masonry style and rail. So there we have it. One door that can do everything that we need it to do, just by following. Obviously there's a lot of steps involved, but again, once you make this, you should never have to make these style and rail doors again. You might just have to eventually change the parameters of it depending on your future project. So that's how to make a Revit door that has all the detail that we want to see when we're looking at it in plan, when we look at it in elevation, and also in 3D, and gives us these opportunities again to open and close not only the 3D panel but the 2D door swing.